All right, so just some logistics, obviously, on the test, because this is your first one. It is going to cover P2 to P4a. P2a, B, and C were all on your quiz. So it's that stuff plus the adding and subtracting and multiplying polynomials, and then the stuff that we factored, the first parts of the factoring, the 3 different kinds. It's going to be 15 questions. It is all open-ended, no multiple choice. There's no calculator, okay? And you'll have the full class period. So in P2, which is what was on your quiz, like all this first stuff was on your quiz, we talked about exponents and radicals, okay? The first thing we did with exponents is adding something that had exponents, whether they're a base that's a variable or a base that's numeric, okay? When we add them, so let's say it was like x to the third plus 2x to the third, we can only combine them if they are like terms, and we keep the exponent the same. So don't change the exponent. Add or subtract here. This would be a 1x to the third plus 2x to the third or 3x to the third. We did the same with radicals. So if it was 2 square root 3 plus 3 square root 2, these cannot be combined. But 2 square root 3 plus 3 square root 3 became 5 square root 3. You leave the radical alone and you combine the coefficients. Then we got into multiplying with exponents and radicals, okay? When you're multiplying with the exponent, you add the exponent. So if it said x to the third times x to the second, this becomes x to the fifth. We add the exponents. If it's got a coefficient like 3x to the third times 2x to the fourth, we'd multiply what's on the outside. So this would be 6. And then you add the exponents on the base. We'll get back to multiplying radicals because the rules are a little different. If you're dividing with exponents, you're going to subtract the exponent. And you keep it where it is larger. So if it was x to the seventh over x to the third, the exponent in the top is bigger, so I would subtract the 3, cancel it from the bottom, and I get x to the fourth. If it's the reverse, x to the third over x to the seventh, this time we would put it in the bottom, so it'd be 1 over x to the fourth. If you have coefficients on here, so let's say it said 3x to the third over 15x, then we're going to simplify the coefficients. Like 3 goes into itself once, into 15 5 times. And then the exponent on that x is 1, so I'd subtract it where it's larger, which is in the top. And I'd end up with x squared over 5. When you're raising a power to a power, you multiply the powers. So if I have x to the third raised to the 7th, this becomes this comes x to the 21st. If it has a coefficient, so let's just say it said 2x to the third raised to the third, they both get that exponent, so it'd be 2 to the third and then x to the third raised to the third, which is x to the 9th. Don't multiply these. So a lot of people do that on the quiz, right? They distribute the exponent, and if it's a coefficient, they multiply. You only multiply the exponents. So this would become 8x to the 9th. And if it's a fraction being raised to an exponent, every term in that fraction gets the exponent. So the 2 to the third, the x to the third, the y to the 9th, or 8x to the third over y to the 9th. Joey?
What if that 3 was negative?
Then you flip it. So that's good segue. Negative exponents was next, right? So the negative exponents with these, we move numerator to denominator or denominator to numerator. So if it's x to the negative 2 over y to the negative 3, they would both switch. So y to the third would go to the top, x to the second would go to the bottom. Only what's negative moves though. So if there was a 2 on the front, the 2 would stay because that negative exponent is not on the 2. If the negative's on the outside, so let's say it said 2x to the negative third over y to the third, and it's all being raised to the negative second power. You have two options there. Either distribute the negative exponent first and then only move what's negative, or flip what's inside. And when you flip what's inside, it only makes the exponent on the outside become positive. So if I'm going to do that, the 2 and the x to the negative 3 go to the bottom, and notice that the exponent stayed negative. The y to the third goes to the top. The only thing that changes is the exponent on the outside becomes positive. Then you would distribute, so this would be y to the 6th over 2 to the second, or 4, x to the negative 6th, and then the x to the negative 6th would move. So I'd end up with x to the 6th, y to the 6th over 2. Oh, no, sorry, over 4. No, the sign didn't change. Then we had fractional exponents. So anything that was raised to a fractional exponent, like if it was x to the 3/2, the 2 slides over, so this is the square root of x, raised to the third power. We mostly did these with numerical values, like 49 to the, actually, let me make a smaller number. 16 to the 3/2, which becomes the square root of 16 to the third power, or 4 to the third, which is 64. And the one on the quiz was both a fractional and an exponent, right? And negative. So you had something like 16 to the negative 3/2. That tells me I'm going 1 over 16 to the 3/2, which is 1 over the square root of 16 to the third, which is 1 over 4/3, or 64. The negative does not change the value on the sign on the actual base. It just moves it. All right, so some special cases with exponents. Anything raised to the 0 power is what? 1. anything raised to, let's say, the 1/2 would be the same as what? Square root. Yeah, hang on just a second. Square root. And you cannot, so like the negative on the value, if it said -5 squared, what's that answer? -25, whereas if it's in the parentheses, what's the answer? 25. I had -25 to the 1/2. Can that be done? It can. The negative would go in the front, and then we'd square root the 25. That'd be -5. If it said -25 in parentheses to the 1/2, that cannot be done because you're trying to find the even root of a negative number. So that's the only time you're going to get no solution is if you're trying to find the even root of a negative number. You can find the odd root of a negative number, but you cannot find the even root of a negative number. Okay? Then we went into radicals, right? And so you did the simplifying of a radical. So if I had the square root of 200, you're going to break it down into its factor tree. This would be 2 and 100, which can either be 10 and 10, and you can bring it out then, or it'd be 2 and 50, 5 and 10, 2 and 5. And for each pair of numbers, one's going to go to the outside. So this 2 brings 1 to the outside. These 5s bring 1 to the outside. If I bring more than one thing to the outside or there's already something there, we multiply that out. So this would be 10 on the outside. Whatever's left underneath by itself stays under. And if there's more than one of those, we multiply them out. So that was simplifying. Then we add and subtract. And we talked about this already, actually. Can only be done if square root is the same. So 2 square root 3 can only be added to something that has a square root 3. Or subtracted, same thing. 2 square root 3 minus 5 square root 3 would be -3 square root 3. Then we got into multiplying. Radicals must have same index. So you can only multiply a square root with a square root and a cube root with a cube root. You cannot multiply a square root and a cube root. So for these, you might see something like the square root of 10 times the square root of 15. And the bigger the numbers, the more I would say do not multiply those out underneath the same radical and then simplify. You're going to keep them both underneath the radical and then break them down. So this would be 2 and 5 and 3 and 5. And now a pair of 5s goes to the outside. The 2 and the 3 would get multiplied together underneath. If it was 2 square root 3 times 3 square root 5, you multiply what's on the outside together, so it would be 6, and what's on the inside together. Square root 3 and square root 5 are not going to simplify, so it would be square root 15. If you have the variable in the front, or the radical on the front, you're going to distribute this to both, and we're multiplying. So because 2 and 5 are the coefficients, those would get multiplied together. Square root 3 stays. And then I go to the next one. 2 times 5 would get multiplied together. Square root 3 times square root 15, or square root 5 is 15. You always want to make sure that you can't break those down though. Just be careful. And then you might have to FOIL. So first here would be 8 square root 3. Outer, 2 times 2, which is 4. Square root 3 times square root 7, square root 21. Inner. And last. And then I would check all of my terms, make sure 1, I can't simplify, 2, like simplify a radical, 2, I can't combine like terms, and there's no like terms there, so they literally would stay like that. Yeah.
If you ever just have to binomials, no matter what it is, you always FOIL.
Yep, just be careful. They have to be up against each other like that. They literally are multiplying. So people tend to forget, and when they see a plus between them, they FOIL it out. If it's a plus, you're combining like terms. Okay, then came dividing radicals. And for these, we had to either simplify or rationalize if the square root's in the bottom. So if I had square root 15 over square root 5, they are both under the root. So I can literally say 5 goes into 15 3 times, and this is square root 3. If it's the reverse, square root 5 over square root 15, the 5 goes into the 15 again, but then I have 1 over square root 3, and that has to get rationalized. So we multiply both the top and the bottom by the square root of 3, and I get root 3 over 3. Yeah.
When is it necessary to rationalize?
Anytime you've got a square root in the bottom. And then we had ones that would have said something like 1 plus square root 2 over square root 2 plus 3. Actually, I mean, most of the times it was the switched order. So the numerator one is fine. The problem is the one that's in the bottom. We can't keep it there. And this time, it's a sum or difference. When it's a sum or difference, we multiply by its opposite. So what's opposite of 2 plus root 3? 2 minus root 3. And we do that in the top and the bottom. In the numerator, distribute 2 minus root 3 plus 2 root 2 minus square root 6. Nothing gets simplified there, and no terms can be combined. In the denominator, this is where our shortcut comes into play. A squared minus b squared. So 2 squared minus the square root of 3 squared. 4 minus 3, which is 1. And then I can eliminate the 1 because anything over 1 is itself. But be careful, because if it said something like the square root of 2, and the bottom was 2, you cannot cancel that into just part of your numerator. So if that had said 2 here, I can't go this, okay? It has to be everything in the sum or difference that cancels out. So all of that stuff was on the quiz. On the review assignment, I put like an additional version of a quiz. Like I came up with questions that were similar to the ones that were on the quiz. So feel free to practice them if you need to, okay? That was all radicals. I feel like the good news is like P3 was a little bit easier. In P3, you're adding and subtracting polynomials. So for these, we just combine like terms. Be careful here, we don't change the exponents. And if there's a minus, you've got to distribute it. So if it said 2x squared minus 3x plus 1 minus 5x squared plus 2. Actually, let's make it minus 2. Then you would distribute this negative to everything after. So 2x squared minus 3x plus 1 minus 5x squared plus 2. And then I'd combine my like terms, negative 3x squared. There's only one term with an x to the first. And then 1 plus 2 would be 3. When we're multiplying, you're either doing like a monomial times a polynomial. So it would have been like 2x to the third times 3x to the fourth minus 5x. Something like that, where you're distributing. So when we're multiplying, we would multiply those coefficients out. 2 times 3 would give you 6. X to the third times x to the fourth. We add the exponents. So it'd be x to the seventh. And then 2x to the third times a negative 5 would be negative 10x to the fourth. Or binomials, and we FOIL. First, outer, inner, last. And then you had your special products, where you can use your shortcuts or you can FOIL them out. The first one was the opposites, a plus b times a minus b, and that is a squared minus b squared. I would highly recommend that shortcut. That one saves time, and it's not so bad. Then you had the 1 raised to the second power. So we square the first term. We square the last term. And then you do 2 times the product. The first and last will always be positive. The second one will be the sign that's in between, because you're going to double that product. So if this sign was positive, the middle term's going to be positive. If that sign is negative, the middle sign is going to be negative. So if it's plus, right, and then if it was minus here, the only thing that changes is the sign on this middle term. They match your original sign. But if you just multiply it out, you'll get that. And then the cubes, which honestly I told you, sometimes it saves time. It does save a little bit of time, I would say, but it's complicated. If you don't remember it, then you're just going to expand. You're going to FOIL the first 2, and then you're going to multiply it out. But the pattern is the first one cubed, the last one cubed, and the sign would come from the term. So this is going to be plus or minus depending on the sign here. And then this is going to be plus or minus depending on the sign again. So it would be 3a squared b, and then plus or minus 3ab squared. So those signs will change depending on the sign in between. Questions on the polynomials? Okay, and then the last one was the factoring we just finished. So you've got your difference of 2 squared. Well, let's go in the same order. Greatest common factor, difference of 2 squares, and perfect square trinomials. So the greatest common factor, you're just going to factor out what's common with the value, like the common factor of the numeric value, and then also your variables. The difference of two squares, you're going to square root the first, square root the last, put a plus and put a minus. And then the perfect square trinomial, you're going to do the test first, square root first, square root last, and double the product. If it matches the middle term without the sign, then it's a perfect square trinomial. And then to factor it, we square root the first, we square root the last. Sign comes from the middle. Put it in parentheses and square it. Joey.
Do you multiply it by 2 or square it?
For which part?
For the test.
For the test, you double the product, so you multiply by 2.
Okay.
So square root first, square root last, find their product, and then double it. If it matches the middle term, then you do the square root, sign from middle, put it in parentheses and square. So questions on concepts, because obviously we want to get to some questions, like actual problems. Yeah.
Yeah. So when you put it in there, do you have to square root it after you put in the minus sign or the plus sign?
Correct.
So, no.
Wait. Say that again.
You have to put it to the power of 2. Like let's say it was 3 and 5.
After you square root it?
Yeah.
Yeah.
You do the whole thing,
And then you have to put it in the parentheses and square it. Is that what you mean?
Yeah. You have
Yes.
to do it like 9 and then 25.
Yes.
You
You have to
put in-
square root it. No, the number that's in there is square rooted.
No, I'm talking about to the power of 2. Is that active or no?
So if this is 9x squared, and then this is 25, so this would be 3 times 5, that's 15. This would be 30x. When you factor it, it's 3x and 5, and then you take the sign from the middle, you put it in parentheses and square it.
Okay, so at the final part right there where the 2 is, do you just leave it?
Yep,
Okay.
that's it factored. Hadley, what's that?
Can you give an example of the difference?
Well, I'm going to go to your homework because that's where you had those. Yeah. So this is from the WebAssign homework. What number was that? 10. Okay. So there's two terms with a minus between, right? They're both perfect squares. So I know this is the difference of two squares. To factor the difference of two squares, we're going to, first of all, I would also see if I could take something out, which you can't. I'm going to square root the first term. So the square root of x to the fourth would be x squared and x squared. I'm going to square root the second term. So it would be 4y squared and 4y squared. One gets a plus and one gets a minus. Then I'm looking at my answer as it is, and the first one is prime because it's a plus. They're both perfect squares, but it's a plus. But the second one is the difference of two squares again. So the first one is going to stay as it is, but the second one, I can square root the first term, square root the second term, and one gets a plus and one gets a minus. Other questions from the homework? Madison,
Can you do number 8?
can you read it to me?
Yeah, I'm getting the website.
Oh, okay.
I have number 8.
Okay, go.
25 minus z plus 5 in parentheses the square root.
Squared, right? Okay. So this is also the difference of two squares because those are two perfect squares with a minus between. So same process, but it looks weird. I'm going to square root the 25, so it's 5 and 5. I'm going to square root z plus 5 squared, which is actually z plus 5 and z plus 5. And then one gets a plus and one gets a minus. Now that minus is going to get applied to both the z and the 5, and that's the tricky part there. On the first one, I'm going to combine the two 5s, so I can do z plus 10 or 10 plus z. The order wouldn't matter there. But on the second one, this becomes 5 minus z minus 5. So the z plus 10 stays, but these 5s are going to cancel out, and it's just negative z. So I would say the good news is, like, for your test, we went pretty light on the factoring. It will come back in further. When we get to factoring completely, which is the very end of P4, all this stuff will get brought in. So like that next quiz or test, you're going to start to see things a little bit more complex like that. Yeah.
It says negative z minus 10 with the times positive.
It's just, I mean, first of all, this is right. So that's a format thing. That's not a big deal. It says negative z minus 10, so they changed the signs on both of them. Yeah, it doesn't matter. Because it's negative z minus 10 times a positive z, right? That's what they did?
Yeah.
Both answers are right. Yeah.
I have a question on 6.
Okay, give me.
It was 32 minus 72z squared.
Okay, so it's a two-termer, right? But they're not perfect squares. But what do they have in common? Like, what goes into both 32 and 72?
8.
8. So I could take out an 8, and I'd get 4 minus 9z squared. Now, 4 and 9z squared are both perfect squares, minus between them. So I'm going to factor that out. So I'd get 2 and 2, 3z and 3z, and 1 gets a plus and 1 gets a minus. So you just got to keep going till you can't go any further. Other questions from the web assigned homework? Valerie.
Could you do number 12?
Can you read it to me?
Is 4t
4, second. 4t squared plus 4t plus 1. Okay, so first of all, it's a trinomial, right? They can't take anything out of it, so it's not greatest common factor. So the second trinomial that we did was the perfect square trinomials. Look at the first term. Is 4 a perfect squared? Yes. Is 1 a perfect square? Yes. So I'm going to test it out first. I square root the first, so I get 2t. I square root the last, I'd get 1. I double that product, and I get 4t. So because it matches, I know this is a perfect square trinomial. That's the test. To actually factor it, you're going to square root the first term. You're going to square root the last term. You're going to get the sign from the middle. You're going to put it in parentheses and square it. Any other questions from the web assigned homework? Keep going.
could you do number
13.
13? 25x squared minus 30x
Plus 9?
Yeah.
Okay, so again, 3 terms. Nothing in common to factor out. First and last are perfect squares. So I'm going to test it first for the perfect square trinomial. Square root this, it's 5x. Square root this, it's 3. Double the product, so the product would be 15x. Double it, and it's 30x. I ignore the sign for the test. Those terms match, so I know I can factor it. So to factor it, we square root the first term, we square root the last term, we take the sign from the middle, put it in parentheses, and square it.